All right, we're going to continue working on in chapter 3 with inequalities and working with sets. Now today's chapter is less about the math of it and more about the language of it and how to represent the math in notation form, some different notations. So you want to pay attention to those and take some really good notes so you can refer back to it. Now this is it'll be foreign until you get used to using it. Let's go ahead and get started. Recall from lesson 1.3 that a set is a collection of distinct elements. A subset contains elements from a set. So you have a set of information, a subset comes from that. For example, the number 6 on the telephone keypad corresponds to the set M and O, but the set MO is one subset of that set. As part of your essential understanding, sets are the basis of mathematical language. You can write sets in different ways and form smaller sets of elements from a larger set. You can also describe the elements that are not in a given set. So that's it. We're going to do a couple different things today. We're going to look at sets, and we're going to look at the smaller sets, and then we're going to look at not part of the given sets. Those are like the three things we're considering. Now, a couple different ways you can write it is in roster form, and that's the one we're more familiar with, using braces. For instance, you would write this set containing 1, 2, and 3 as 1, 2. You would write multiples of 2 as 1, 2, 6, 8, or 2, 4, 6, 8, and then you would use our dots to indicate that the list continues on. This is what we call is in roster form, kind of giving a roster of information. The one that's more unique that we haven't done a whole lot of is set builder notation, and we're going to practice that a lot today and tomorrow. So another way to write sets is described as the properties an element must have to be included in a set. So it's like the descriptions, and if it fulfills that description, it gets to be in it. For example, you can write the set 2, 4, 6, 8 in set builder notation as, so right here, here's our set builder notation as, and you would read it as, this is a set of all real numbers x such that, and here's your such that, x is a multiple of 2. So you read it as your variable, as the set of all real numbers, such that, that's your line, that x is a multiple of 2. You got to practice this out a little bit. So let's start off with this thing. So right now you see it in roster form here, where t is a list of all natural numbers that are less than 6, and you can see them there, 1, 2, 3, 4, 5. In set builder notation, we would write it this way. It's all real numbers such that x is a natural number where x is less than 6. And you're going to use your variable, and you describe the limits on that variable. So here's where our starting point is our x, and then after the such that happens right here, you're indicating what qualifies as part of that. I'm going to have you give it a try. So let's press pause and you do the got it number 1. All right, so here, let's see how you did. So in roster form, this is the form we're more familiar with. And then set builder notation, looks like this, where it says x, all real numbers, such that x is an even natural number where x is less than or equal to 12. You can use set builder notation to write the solutions of a linear inequality as well. I'm going to first look at this inequality here. I'm going to press pause and solve this out real quick. All right, when I played this out to try to figure out what x is in the inequality, a couple things I noted that I wanted to pay attention to is that because I did divide both sides by -5, my symbol does indeed flip. So I'm going to look up here, and it's asking which one is in set builder notation. There's a couple I can pull out. That one is not it. That's in roster form. This is just, I guess I'd put that like in solution form. So it's these two right here. I'm going to make sure they match. Okay, so I'm looking for this right here. And this is telling me that it fits with B, where it says x, all real numbers, such that x is greater than or equal to -2. So B is my answer. All right, I want you to try the got it. In the set builder notation, how do you write the solution of 9 minus 4n is greater than 21? Press pause, give it a try, and let's see how you did. All right, let's see how you did. A couple other details. I noticed that because, again, in green here, I divided both sides by -4, so my symbol had to flip. to keep up with the changes I did. Notice in my set builder notation here that I don't have any extra words, and that's because there are no special requirements like even numbers or odd numbers or multiples. If I have those, then I need to include that in my set builder notation. But right now it's saying that all sets of numbers, all sets of real numbers, such that where n is less than -3. You know that a set A is a subset of set B if each element of A is also an element of B. So if it's all included, you can say that it indeed is a subset. For example, if the set of B is -2, -1, 0, 1, 2, so I'm looking at, here's a set of B, and if A is these numbers right here, and they're included in there, we could say that A is a subset of B. It's included in there. This is our notation for that. You can indicate it this way. A is a subset of B. So that symbol right there represents subset. It's kind of like a C that's been sat on a little bit, curved around. An empty set or a null set, this is a set that contains no elements. The empty set is a subset of every set, so we still include that as a solution. Use our null set, here's our symbol for null set, or empty parentheses, not parentheses, but braces to represent that empty set. So finding subsets, what are all the subsets of the set? Now this is something that we don't always consider, but we do need to look at all the subsets. So it's all the different groups that could make this up. So one subset is an empty set. An empty one is possible. It is a subset of this. Another subset is just looking at with one element, and it's kind of looking at them separately. Another one is considering two elements, so each one and getting all the combinations that happens. And then there's just the original set, which is kind of all of them, and that is included in there. So this subset, the set of numbers 3, 4, 5, actually have 8 subsets that play out on it, and here they all are. This whole list are considered subsets of the original set. I want you to give it a try for number 3 here. Press pause and work it out. Here you can check your answers. The subsets of P, I found 4 of them. The subset of S, I found 1, 2, 3, 4, 5, 6, 7. I found 8 of them that qualify. For B, considering this, is A a subset of B? Being that A represents all real numbers such that X is less than -3, since everything that happens in here is included in this set, the answer would be yes. A indeed is a subset of the set B. When working with sets, you call the largest set you're using the universal set. It's kind of like the biggest set you're looking at, or the universe. A complement of that set, okay, is the set of all elements in that universal set that are not in the set. So the complement of the set is the not set. You denote this by the complement of A with this little tick marker right here. It's almost like you're putting like the little foot sign in there, like when you're indicating feet of a unit. But that little symbol is basically saying not A. So the complement of A is not A. In the Venn diagram below, you can see how it plays it out here. The U represents a universal set. So this whole thing right here is the universal set. And then A sits in this middle. So the set A is a subset of U. And we can see that using our notation. A is a subset of U, our universal set. The complement set plays out like this. You can see that the complement of A is also part of the universal set. It's part of this whole thing, but it's not part of the A, so it's a complement of A. So like not A. Let's see how this plays out though. Like in a game of chess, the universal set, the big set, is all the pieces, the king, queen, bishop, the knight, the rook, and the pawn. Set A, yeah, let's keep reading this out. And the set A is the set of chess pieces that move side to side. So if we want to think of our big universal is all the pieces. You can see it right here. All the different pieces are part of our universal set. And set A is going to represent those that move from side to side. And I don't know chess that well. I'm more of a checkers guy. I probably should check out chess because that looks really cool. But chess people know that only certain ones can move side to side. It is the king, the queen, and the rook. They can move side to side. So when you look at this, as you can say, the king, the queen, and the rook are indeed a subset of the chess piece set. But then we've got some that are the complement of set A, and that's these ones right here. So the complement of set A would be our bishop, our knight, and our pawn. Those are the complement of the pieces that can move side to side. Let's give it a try. You press pause and try this one. I used a Venn diagram to help me kind of see what's going on, but I indicated that my complement, because I'm looking for my complement of set A, and I can indicate that with my symbol there. So it's set A. My complement is everything that is like not A, and I put it in my own roster form. All right. Well, there you go. I'm going to go find a bowl of Jello to dump on my head.